Hello reviewees and JCB viewers, and welcome back to JCB EduBuild Solutions, founded by engineer James Bolo. Today we are going to put your skills to the ultimate test with real questions from past board exams, focusing on sanitation, plumbing design and installation. Let's see if you're ready to tackle this. So, you think you're ready for the board exam? We're about to find out. These are the exact kinds of questions where so many people stumble. The pressure's on. Let's see how you do. Okay, here's the deal. We're going to dive right into these past board exam questions. After I read each one, you'll have exactly 5 seconds to come up with the answer before I reveal it. Think fast and think carefully. Ready to go? Let's do this. Alright, let's kick things off with Section 1, Foundational Concepts. You have to know this stuff cold. This is the bedrock of everything a master plumber does. Question 1. Looking at the figure, what is item number 4? It's what automatically closes the water supply to the cistern. Is it A, a ball cock, B, a foot? Question 2. What do you call the safety valve on a water boiler? Is it A, a drain valve, B, an angle valve, C, a TP valve, or D, a gate valve? You've got 5 seconds. Lock in your answer. The answer is C, TP valve. And here's a tip. Always remember that TP stands for temperature and pressure. It's a critical safety device that protects against both of those things. Okay, time to crunch some numbers. What quantity of heat is required to change 15 pounds of water at 40 degrees Fahrenheit up to 212 degrees Fahrenheit? Is it A, 2,580 BTU, B, 5160, C, 1290, or D, 1890? Your 5 seconds starts now. The correct answer is A, 2,580 BTU. Let's quickly see exactly how we got there. So here's the breakdown. The formula is a classic. Q equals mc delta T. We just plug in our values. Mass is 15 pounds, the specific heat of water is 1, and the change in temperature is 172 degrees. Multiply those together, and boom, 2,580 BTU. You absolutely have to know this formula for the exam. All right, back to the plumbing code. How many water supply fixture units, or WSFU, for public use do we have here? We've got 3 water closets, 3 urinal stalls, 2 shower heads, and 2 lavatories. Are we looking at 30, 35, 40, or 42? You've got 5 seconds. The correct answer is D, 42. Now, let's see how those units stack up. Here's the math. For public use, 3 water closets at 5 units each gives you 15. The 3 urinal stalls are also 5 units each, so that's another 15. The 2 shower heads are 4 units each, for a total of 8. And finally, the 2 lavatories are 2 units each, which is 4. You add it all together. 15 plus 15 plus 8 plus 4 gives you exactly 42 WSFU. These are standard values from the code. You just have to memorize them. Okay, last question this section. As a master plumber, if you see 2 or more drain lines for a disposal field, what are you going to require? Is it A, a dosing tank, B, a septic tank, C, a distribution box, or D, both A and C? 5 seconds, make your choice. The correct answer is C, installation of a distribution box. This is crucial. The whole point of a distribution box is to make sure the effluent spreads evenly across the entire leach field, preventing one area from getting overloaded. And that's Section 1 in the books. Great job. Let's move on to Section 2, Systems and Sizing. This is where we start looking at the bigger picture, how all these individual parts come together to form a working system. First up in this section, which one of these chemical compounds is the main player when it comes to the salinity of water? Is it sulfate, calcium chloride, sodium chloride, or magnesium carbonate? You've got 5 seconds. The answer is C, sodium chloride. Don't let the fancy name fool you, that's just table salt, and it's the primary thing that makes water salty. Question 7. What's the proper term for the water that flows out of a sewage treatment facility? Is it a solution, potable water, effluent, or sewage? You've got 5 seconds on the clock. The correct term is C, effluent. This is a really important piece of terminology, so let's lock in exactly what it means. So, effluent is the wastewater flowing out of a treatment plant. It's often confused with sewage, but sewage is the raw, untreated wastewater that flows in. Knowing the difference between what comes in, the influent or sewage, and what goes out, the effluent, is absolutely fundamental. Let's get back to sizing. Given 3 public water closets, 2 lavatories, 2 floor drains, and 2 service sinks, what is the minimum diameter of the soil stack? Is it 76, 65, 102, or 152 millimeters? You've got 5 seconds. The right answer is C, 102 millimeters. And here is the key rule of thumb from the code. Anytime a soil stack serves more than 2 water closets, it has to be at least 4 inches, which is 102 millimeters. Okay, follow-up question. For that exact same system, what's the minimum size for the vent stack? Are we talking 38, 51, 65, or 76 millimeters? Lock in your answer. The correct size is B, 51 millimeters. So the vent stack size is directly related to the soil stack, and a very common requirement is that the vent has to be at least half the diameter of the soil stack. In this case, that's 2 inches or 51 millimeters. One more question on vents. What is the maximum allowed length for the main vent in this scenario? 18 meters, 37 meters, 12 meters, or 55 meters? 5 seconds. The correct answer here is B, 37 meters. Now, this is a bit of a trick question because this isn't a number you calculate. This is a value you have to look up in the plumbing code tables, and it's determined by the vent's diameter. Knowing where to find this info is just as important as knowing the formulas. Excellent work. You've officially made it to our final section. You could call this the boss level. Section 3, Codes and Materials. This is where we get into the real nitty-gritty details of the rules and what you can and can't use on the job. First question of the final round. Which of these materials is not listed in the code for use in water piping? Aluminum, asbestos cement, cast iron, or plastic? You have 5 seconds. The correct answer is A, aluminum. And the reason is pretty simple. Aluminum corrodes very easily when it's in contact with water, making it a totally unsuitable and unapproved material for water supply lines. Next up, what is the standard distance a vent opening must terminate above the roof deck? Is it A, 0.9 meters, B, 1.2 meters, C, 3 meters, or D, 2.1 meters? Lock it in. The answer is A, 0.9 meters. This is one of those specific numbers from the code that you just have to know. It's there to make sure dangerous sewer gases are vented safely away from the building and anyone nearby. Time for a little fluid dynamics. What do we call the measure of inertia forces versus viscous forces, which helps us describe if a flow is turbulent or laminar? Is it the Froude number, the Weber number, the Reynolds number, or Moody's number? 5 seconds. The correct answer is C, the Reynolds number. Let's take a quick look at why this number is so important. The Reynolds number is this really crucial dimensionless value that helps us predict how a fluid will behave inside a pipe. A low Reynolds number means you've got smooth, orderly, laminar flow. A high number means you're dealing with chaotic, turbulent flow. Understanding this is absolutely essential for proper system design. All right, let's talk about copper. How can you make changes in the direction of copper tubing? With A, bending equipment, B, metallic fittings, C, plastic fittings, or D, a propane torch? You have 5 seconds to decide. The correct answer is A, bending equipment. Now, of course you can use fittings, but the code specifically allows for bending soft copper. Why? Because it creates a nice smooth turn without a joint, and that means you've eliminated a potential point for leaks down the road. And here we are, our final question. What is produced when magnesium salts are present in water? Is it mineral hardness, permanent hardness, total hardness, or temporary hardness? This is it. You've got 5 seconds. The correct answer is B, permanent hardness. The key thing to remember here is the difference. Temporary hardness can be removed just by boiling the water, but permanent hardness, which is caused by sulfates and chlorides, cannot be removed that easily. And that's the challenge. You made it through. Great work. So how did you do? Let us know in the comments. And for more board exam reviewers just like this one, make sure you follow JCB EduBuild Solutions. Thanks for joining us, and we'll see you in the